For many patients, finding a clinical trial that fits their medical condition feels like reading a foreign language. Navigating thousands of listings is overwhelming, medical jargon is incomprehensible, and sharing sensitive personal details online can feel incredibly unsafe. So, hello everyone. Today, I am excited to show you Health Navigator, an intelligent assistant designed to solve this exact problem by making trial discovery secure, simple, and patient centric. So, why agents? A standard chatbot or single prompt system cannot safely navigate this complexity. It is too easy for a single model to get confused between searching databases, translating terms, and securing data. Instead, we built an agentic system with specialized subagents. We have a trial matcher specialist that searches databases and an eligibility simplifier specialist that focuses only on decoding terminology. This delegation allows each agent to use narrow, highly optimized tools, ensuring accuracy, security, and predictability. Let's talk about the build. Health Navigator is built using the Google Agent Development Kit 2.0. We implemented a graph based workflow in Python that manages the session state and controls the execution path. To connect our agents to our internal clinical trial and medical translation databases, we built a custom model context protocol server that runs locally over Studio. This ensures that the agents interact with our data sources through a secure, well-defined tool interface rather than direct database access. Let us see it in action. First, I'll ask it to show me clinical trials recruiting for lung cancer. Under the hood, the security checkpoint authorizes the input. The orchestra delegates this query to the trial matcher specialist. Trial matcher specialist then invokes the MCP search tool and returns the recruiting trial NCT 011234556. Second, I will ask what are the eligibility criteria for NCT 011234556 and can you explain what NSCLC and ECOG mean? The orchestra recognizes that this is an eligibility question and delegates it to the eligibility simplifier specialist. The specialist queries the MCP database to fetch the trial details and translates NSCLC to non-small cell lung cancer and ECOG to the physical activity scale, presenting them in clear layman's terms. Third, I will request that I want to apply and provide my necessary details such as my name, email, and my SSN. Notice what happens. First, the security checkpoint immediately scrubs the SSN to prevent PII from reaching the LLM. Then the orchestra executes the registration tool, updating the workflow state. Finally, the workflow routes to the registration checkpoint node, which triggers a human in the loop consent pause. The playground UI interrupts the chat asking, do you consent to share your name and email with the study coordinators? When I reply yes here, the consent is registered and the registration details are securely forwarded. Henceforth, security is at the core of Health Navigator. Every user input goes through a dedicated security checkpoint node. This checkpoint screens for prompt injections, enforces a minor protection policy, and redacts PII. It also logs every decision in a structured JSON audit log. Additionally, the model context protocol encapsulates all data access, shielding the database from prompt injection. Health Navigator empowers patients by demystifying complex medicine and automating clinical trial discovery while keeping data security and human in the loop consent at the forefront. Thank you.